Hi, Assalamualaikum. We are from Group 2 from BMP 22502, Statistic for Engineering Technology, Section 5. And this is our project presentation about the vehicle dataset from Cardecko. So, in this project, we are investigating the vehicle dataset from Cardecko that gives useful dataset for price prediction of cars in different years. Besides that, the vehicle dataset includes information about cars and motorcycles listed on Cardecko. The data includes column for models, years, selling price, showroom price, kilometers driven, fuel type, seller type, transmission, and number of previous owners.
Chapter 1 is a random variable is real value function that is defined across the sample space of a random experiment. In other words, the random variable value matches the result of the random experiment. There are two types random variable. One is discrete and one is continuous. A discrete random variable can take accountable number of distinct values. So from this data, we can use discrete random variable method to find the quantity outcome of a random occurrence. So next, use the probability distribution function to find a random variable average or mean value. X is the expect value. This value or result has the highest possibility of occurring. For example, EX for the expect value of X, or EFX where the function f is user sample value. The dominant of X are common way to represent. After we get the result of PDF, we will go to use CDF. For the cumulative distribution function, calculation is used characterize the probability distribution of random variable. The cumulative distribution function is utilized. It can be used to express the likelihood of a discrete, continuous, or mixed variable. This is calculated by adding a probability density function, the cumulative probability for a random variable. Last step, we can find the mean X, variance X, and standard deviation by using table the probability distribution function. The mean, we will total up the value of EX to get the mean, and also EX square, total up the EX value as EX square to find the mean of EX square. After we get the result of mean, we can use the result to get variance. Variance formula is EX square deduct with EX square to get the result variance. After we get the variance value, we can square root it to get the standard deviation value from this data.
Assalamualaikum and hi, my name is Nurul Syuhada binti Zaita, and now I'm going to present about the study case of chapter 2. For the chapter 2 study case, we choose the binomial distribution topic to solve our question. So the question is, an article reported that 60% of Malaysian drivers use their mobile phones while driving their cars. If 30 drivers are selected randomly, compute the probability that exactly 20 of them use a mobile phone while driving their cars. So the solution is, we know that n is equal to 30, p equals to 0.60, q is equal to 0.40. So the mu, which is np, we get equal to 18. So the nq is 12. So since the np and the nq is more than 5, we use the normal distribution to solve this problem. So by using continuity correction, we found that probability px equal to 20 is p 19.5 less than x and 20.5 less than x. So we do the continuity correction and we get that the probability 20 of them use a mobile phone while driving their car is 0.115. Thank you.
Assalamualaikum. My name is Adi Abu Bakar Muhammad Zaki. For chapter 3, sampling distribution, for the question, assume that the vehicle speed on certain lengths of road are regularly distributed with an average speed of 35 mph and a standard deviation of 1.6 mph. For A, find the probability that the speed of X randomly selected vehicle is between 34 until 39 mph. For the second question, determine the probability that the mean speed of 30 randomly chosen car is between 34 and 39 mph. Okay, for A, solution, given that mean equal to mu equal to 35 and standard deviation equal to 1.6. Using the table, we got probability 34 and 39. That we use Z table again, and we got the probability is 0.7262. For B question, n equal to 30, mu s bar equal to 35 and sigma s bar equal to 0.29. Using the table, we got the probability equal to 1.
So in chapter 4, we're doing estimation in finding the difference between two means of D cars and M cars. So as we could see, the number of sample for both are equals, which is 15 cars for each. And since the N1 and N2 are equals and both are below than 30 and the variances are unknown, we will use the T distribution to solve this question. So by inserting the given and calculated value into the case 1T distribution formula, we will get the answer, that is 1.395 to 3.605. So from here, we can conclude that we are 95% confident that the difference between the mean MPG ratings of the two car types is from 1.395 to 2.605 MPG, with the D car having the higher MPG.
Hi, now I'm going to present to you about the study case of chapter 5. The question is, a manufacturer of car batteries claims that the life of his batteries is approximately normally distributed with a standard deviation equal to 0.9 years. If a random sample of 15 of these batteries has a standard deviation of 0.7 years, test the hypothesis of variance population greater than 0.69 years by using 0.01 of significance level. For the solution, first step, we need to find the HO and H1. HO, we get the variance is equal to 0.69, and for H1, we get the variance is more than 0.69 and claim. For the step 2, by using alpha equal to 0.01, the critical value that we get is 29.141. And then by using the chi-square distribution, the decision rule that we get is reject the HO if the last value X test fails in the rejection region. So for step 3, we found the X test value, and the X test value is 8.46913. For the step 4, we know that the test value is less than the critical value, so the decision is do not reject the null hypothesis. There is no enough evidence to support the claim that the life of his batteries with variance greater than 0.69 years. Thank you.
So I'm going to talk about chapter C, which is, our question is, assume that there is linear relationship between the speed of car driving and with the distance taken. 30 different cars were the same variety were selected and observed. The distance of the car were in kilometer. So the first question is, plot a scatter diagram of distance y against amount of speed s, and then we got the straight line for the scatter plot, and then the second one is calculate the equation at least square regression line of y on s. So first one, we got the summation of x is 2124, summation of x square, and we got the summation of y, summation of y square, and then after we get the value of summation, then we find the SSY and SSZ to find the B1, and then after that we got the B node, and the Y bar is negative 39.86 plus 0.721678s. So we can conclude here, when the speed of car increased by 1%, the amount of distance also increased by 0.72167. That's all for the chapter 6. Thank you. Finally, using case study that was studied using a total 247 variables, this project has been successfully completed, and although the case study from every chapter have gone through research and only the finest one presented in the report. For each case study, the proper calculation and method have been calculated, chosen and accurately selected. In some way, this research has given the selected subtopic for each case study that has been studied with deeper expertise. Additionally, this assignment gives us a chance to prepare for the final exam. There were several things we discovered while we worked on this project, and one of them was the need of communicating any problem with the entire group. We owe a lot of gratitude and appreciation to Dr. Siti Nur Ashikin binti Muhammad Razli, who always helped us enormously in finishing this project. Thank you for our group.